Section 2.1 Linear Equations. So we will see what are the equations. Like we will focus on algebraic equations. Now these are the when we say equation, we mean mu'adala. In Arabic, it's mu'adala, and there will be always an equal sign and the unknown variable x, or it might be more than this. So the letter x is the unknown variable. When we say a solution of an equation means a number which satisfies the equation. So, for example, 3 is a solution of x squared equal to 9 because 3 squared is equal to 9. And also, you will use this word, 3 satisfies the equation x squared equal to 9. So it means when you substitute 3 for x, so it will satisfy the equation 3x squared equal to 9. Solution set of an equation is the set of solutions of a set. So for example, the solution set of x squared equal to 9 is negative 3 and 3 because 3 squared is equal to 9 and negative 3 squared is equal to 9. Now, in the questions, you will see this phrases, solve the equation or find the solution set or solve for x. They're all asking you to find the solutions. Now, equivalent equations are the equations that have the same solution set. For example, look at this one, and look at this. These are all equivalent because they have the same solution set. Okay, one thing, for example, x squared equal to 4 is not equivalent to equation x equal to 2. What's the solution set for it? It's negative 2 and 2. But when you look at here, it will be only 2. So as you see, they're not equivalent equations. Solving linear equations with one variable. Linear equation, when we say linear equation in one variable, it's an equation that contains the first degree of variable, or first power. Let's say this first power. You don't see x squared, but you see the first power of the variable, and it can be converted to this one. This we can call it standard form, and a, b are real constants, and a is not 0 here. And here x is the variable or unknown. We could say also unknown. X is the unknown variable or unknown. Now some examples. Here, look at here this x, the first power, first power. So it's linear equations. These are called linear equations. But here we have the half power. We have x to a negative first power, and we have a square here, so these are called nonlinear equations. Some of these can be converted to some linear equation, but in general, these are called nonlinear equations. The solution strategy is very straightforward. You will convert means change a linear equation to x equal to a using the following properties. These are properties are listed here. It's about the addition, subtraction, multiplication, and division. Basically, the rule is whatever you do to one side, do the same to the other side. So it means when you add c to both sides, or when you add c one side, do the same thing to the other side. Now when you subtract c from one side, do it to the other side, and multiply one side with c, you have to multiply with c the other side with c, and divide in division, you have to divide both sides with the same c. So let's look at this example here. So there are two types of doing it, like two approaches. One way is this. Let's say the first way. This is for the beginners. You write 15 and subtract 1 from each, and they cancel out. And 14, it's 2x equal to 14, and you divide by 2, so x equal to 7. And the second way is it's not for the beginners. It's if you have some experience, you have, okay, you take the equation and you say, okay, I have to collect x as one side and the other numbers this side. Okay, just send this one here as minus. Okay, so it will be 15 minus 1 2x, and you have 2x equal to 14, which gives you again x equal to 7. And here in this rule here, if you have an equal sign here, when you send here plus to the other side, make it minus here. Or if you have plus here, you go here as minus, and the same way. So when sending one term to the other side, change its sign. This is the most important thing here. Okay, then, so you will see the standard way. Now, let's look at this example. In solving the example, solving an equation, you are trying to do some operations to get this one. So you have to isolate x. X has to be here alone, and that will be a number here. So you have to use the operations this way. So first, let's get rid of the parentheses first. These are the parentheses. Okay, let's see. And then remove the parentheses, distribute the minus sign here. So you see here this and here minus plus. So it will be here minus minus, and this will be a minus plus, as you see. And then the next thing here is you can send the x is one side and the other numbers here. So I don't know how it goes in the slide, but you can do it this way. Like send this one here and send this one here. So this becomes plus 1 and this becomes like plus 2x, and you can cancel them. So it becomes like 1 plus 1 plus 4 minus 2x is equal to 5x minus 8x plus 2x. And then when you do this job, then when you combine them, you will get negative x equal to 6 minus 2, if I am not wrong. So you can do like division by minus 1, divide by minus 1, and you get x equal to minus 4. Okay, you can use the sending issue here. This send, if it minus goes as plus, and in here it's a minus goes here as plus. You can do that. Okay, let's see how it goes here in the slide. Let's see. Okay, 3. It's so first, I mean, you can simplify, or you can, combine these terms, the like terms, the similar terms. It will make 3, and then this part here, 3x. Then you can do this job. I mean, or 3x goes here as plus 3x. You will see now this interchanging the elements in the equation. Like this one goes here as plus, and here this goes here as minus, as you see. And then you have all x in one side, and then you have x equal to minus 4. Now let's do this try and check question. Okay, stop the video and try to do it by yourself. And first I will do it myself. Okay, 7x minus 14 minus 2, and x minus 3x, and then minus 3. And then I can combine these two and these two, and send this one to here as plus 2x, and send this one to here as plus 16. So it will be 7x plus 2x equal to negative 3 plus 16, and this will give us 9x equal to 13, and this will give us x, so 9x 13 divided by 9. So you got x equal to 13 over 9. You can write your answer this way, or you can say the solution set of the equation. The solution set is 13 over 9. But since we are talking about a set, we have to put the parentheses. Okay, some equations will involve fractions. In solving this type of linear equations, you can use least common denominator if the equation has fractions. It has some good advantages. For example, you have 6 and 3, and you don't want to deal with the 6 and 3. What should you do? Okay, first find the LCD of 3 and 6. Okay, find the LCD, least common denominator of all fractions. So here it is 6. You remember that, I guess, like 6 equals to 2, 3, and 3 is just 3. What is the LCD? You take okay, if there is something not common, so you take directly. If there is common elements, you take the highest power. It means like 3 to 1. So it's 6. Now this is 6. You got it? And then we multiply both sides with the LCD, the least common denominator. So here is what we do here. 6, you multiply each with 6. So, and then you distribute 6 and distribute 6. So we got this one. And then, okay, what's the advantage of using LCD? We expect the simplifications like this, and they will make 5x, and 6 and 3, it will make 2. So we will end up with 5x, negative 24, and then 2x, and then send 2x here and send negative 24 here. So you will get 3x, like 5x minus 2x is equal to plus 24, which makes 3x equal to 24. And then x is equal to 8. Then you can write the solution set is 8. Now, some linear equations have no solutions, or some of them will have infinitely many solutions. Now, let's see which type of equations have these properties. Now, solve the equation 2 times x minus 4 is equal to x minus 3 minus x. Okay, the usual, we will try to get x equal to something, and let's try. Remove the parentheses and try to do it, and then we have a surprise here, like 2x here this side and 2x here. When you send this one to the other side as plus 8x, or plus 8, and 2x goes here as minus, so we get a surprising result here, 2x minus 2x equal to 5, which makes 0 equal to 5. So what is the solution then? So here, indeed, this means 0 times x equal to 5. And no value of x makes this equality true. So there is no value making this true. 0 times 1, 0. 0 times anything is 0. So this cannot happen. So we say there is no solution. Okay, there is no solution for this equation. And the bottom line is, if you didn't understand this part, the bottom line is if you get 0 equal to some number, like when you solve a linear equation and you get 0 equal to some number, so you solve it and you got 0 equal to some non-zero number. So it means, this means the equation has no solution. So you can say this. Okay, here Okay, basically the solution set of the equation is empty set, we can say it. And we have another example. Okay, in this example, when we try to solve it, we have another surprising result. So we got 3x minus 3x is equal to 12 minus 12, so which gives you 0 equal to 0. So this, it means that 0 times x is equal to 0. So which values of x makes this true? So whatever you put for x, like for example 0 times 1 equal to 0, for example. So whatever you put there, it's okay, because 0 times anything makes 0. Whatever you put for x, the equality is always true. It's true. So in this case, no matter what you put here, 1, 2, 3, all of them. So you say the solution set is all real numbers. So you say the solution set of the equation is all real numbers. So the bottom line is, if you get 0 equal to 0, so you say the solution set is all real numbers. And if you get 0 equal to some non-zero number, so you say the solution set is empty. Now, stop the video and try to solve this one. Here, this is an application of using an LCD. There are several ways of doing it, but you can use the LCD of 2 and 6, so it is 6. I mean, you can check this one. Okay, now you multiply both sides with 6, so it will be 6 times 1 over 6y minus 6. And then when you multiply these two, what happens is like 6 times 1 over 2y, so you got 3y. And here you have 6 times 6, it will be 6 times 1 over 6, it will be 6 over 6y, and 6 times 6, so it will be here y, and 36. And we end up with 3y equal to negative 36, and y is equal to negative 18. This is the solution. Now you say the solution set is negative 18. Now let's see how to use linear equations to solve word problems. In real life, the questions are related to mathematics in science and technology is not coming in the equations. Generally, it's a real life problem. There's a story of it, and then you change it to mathematics. Now, here are the steps to follow. One, read the problem carefully and try to understand what is given. And then after this, like, try to use some diagrams and tables to write what is given, and then assign a variable, and then write an equation by using the variable and by using what is given, and then solve the equation and state the answer to the problem. So check if it is reasonable or not, and then check the answer in the words of the original problem. Okay, let's look at this example, finding missing number. So this is a classical mathematics word problem, and it uses linear equations. Now look at here, find 3 consecutive odd integers so that the sum of 3 numbers is 1 more than twice the third. So it's asking 3 numbers, and they will be consecutive and odd integers. Consecutive odd integers are like these. Example, 3, 5, 7, let's say 9, 11, but 3 of them, 3 consecutive odd, we will take 3 of them, like 11, or 9, 11, for example, 13. So no other odd number, like no gap between them. I mean, no odd number skipped between them. So 101, 103, 105, this is odd consecutive integers. Three of them, three consecutive odd integers, like for example 99, 101, and 103, for example. So we have to get three consecutive odd integers. So let's say we have the first number and the second number and the third number. Now, what does it tell? The three consecutive odd integers, when you look at them, 3, 5, 7, or like 9, 11, 13, and when you look at them, you will see if they are consecutive, there has to be two difference between them. So it means we don't know the first number, but the second number definitely is like first number plus the plus 2, and the third number is definitely the first number plus 4. So now, as you see, I'm trying to write these in terms of the first number. So this is the way that goes to the equation. So you are trying to get some, you're trying to say something will be used here, and it will open the solution. I mean, it will lead the solution. Okay, that's one thing. And then the second thing is the sum of three numbers, so it means like the first number plus the second number plus the third number. Third number is okay. One more than, okay, it's one more than twice the third. Twice means two times. So it says two times the third number. Okay. Now, the sum of three numbers has this property. That's one. This is given. And the other thing is this. This is important. Now, we know what is given. We did some scratch work. And now, it's better to go to mathematics now. Now, let the first number be x. So here, it requires some experience, but you can see here, this first number used, and it's better we use x for it. Now, let's see what it leads. So then, the first number is x, so then the second number, then the second number is, as you see, first number plus 2, so it will be x plus 2. And the third number here will be x plus 4 then. Now then we will put them in the equation here, I mean in this equality, so it will give us x times x plus 2, and x plus 4 will be equal to 2 times, this is x plus 4 plus 1. Then 3x plus 6 is equal to 2x plus 8 plus 1. And this turns out to be, okay, x minus 2x is equal to 9 minus 6, which is 3. So x is equal to 3. Now, we got x equal to 3. And let's get back to our problem and check if 3 is okay. Now, first, if x is 3, then the first number is 3, and the other one is 5, and the other one is 7. And now, is it true? Does it satisfy this? 3 plus 5 plus 7, is it equal to 1 more than 2 times the third, 7 plus 1? Is it true? This turns out to be 15, and this turns out to be 14 plus 1, so it looks true. It is true. And you say, yes, we checked. It satisfies the conditions on the numbers. So we say, yeah, these numbers, the numbers are are 3, 5, and 7. Okay, let's try to solve this problem. It's almost the same type question. Please stop the video and try to do it by yourself. 3 consecutive even integers. So get some examples and try to imagine how they will look like. For example, 4, 6, 8, or like 12, 14, 16. And again, we have this +2 +3 issue. And okay, so you can say the first number is, let's say first number, and second number is first number +2 again. And the third number is first number +4, sorry, first number. Then after doing this, you can, okay, look at here. It says the sum of the first two numbers is 22 less than 4 times the third. Like before getting there, here this information allows us to say something x. We can assign x to one of them, and this, it will turn out again the first number. So let the first one be x, then the second number is x +2, and the third number is x +4. Okay, now we have the x terms here. I mean, we have all the numbers in terms of x, and then we use this information in setting up the equation. So it says the sum of the first two numbers, which is x and x +2, the sum of the first two numbers, first number and the second number, is 22 less than, so it means you have to put this -22. So this is standing for 22 less than. And 4 times the third, so it means like 4 times the third number. Third number is x +4. It's third number. And then we will end up with this equation, and let's try to solve this equation here. 2x +2 is equal to 4x +16 minus 22. And okay, if you send these here and these here, you will end up with 2x equal to 8, I guess. Yeah, it will be 8. You can check it. So 8. Anyway, we'll see it. So x equal to 4. So the first number turns out to be 4. Okay, let's check it. If it is 4, then we have the first number 4, the second one is 6, and the other one is 10. No, it's 8, sorry. So is it equal, like the sum of the first two numbers, like 4 + 6, is it equal to 22 less than 4 times the third, 4 times 8? Is it true? So we check it now. And this will become like 10 is equal to 32 minus 22, and 10 is equal to 10. Yeah, this is true. So you say, yes, this is a solution here. So you say the solution, so the numbers are, so you have to write in this wording, okay, like you can say the 3 consecutive integers with the given property is or are, okay, 4, 6, and 8. So here we are trying to follow the steps, but steps are not very solid. You know, when solving a word problem, the steps are not very solid. The first thing is you will try to understand what is given and try to write them, try to do some scratch work and see what's given, what is not, and try to figure out which one is the good thing, which is the right thing to assign a variable. And then you will write the equation. These are the important steps, but these are not easy steps. I mean, you need to have some experience to do it. Okay, let's look at this example here, the discounted price example. It says a short was 149 SAR after the discount, let's say, after the discount. So how much was the short before the discount? You can start by saying this is a straightforward problem. So you can say let, x directly, you can write the unknown here as the variable. X is, let x be the short, the price of the short, before the discount. Then how do you get 190 SAR and the 35% discount? So you can say here the discount amount here, amount is 35%, which means 0.35x. So 35 discount means like you multiply 35 divided by 100 times x. So you can write it as 0.35 times x. This is a multiplication. This is the decimal point here. And then the new price, the price after the discount is indeed x minus 0.35x, and which is also given here, it's 49 SAR. So when you do this job, it will be 0.65x. Then you can divide both sides with 0.65, and after using a calculator, you will get x equal to 280 something, 83. I'm not sure. Okay, if we have this rigorous solution, I want to show it here. So this is okay. I don't remember what we wrote in the slide. So let x be the price of short before the discount, and what is given, the short was 49% before, after the discount. So it means the price on sale, the price now is equal to the original price x minus the discount amount, which is 0.35x. So this means our equation, and solve the equation and set up the equation and check the solution. Okay, the short is on sale, 100 markdown, 35 markdown means discount. Okay, discounted. And we check it. 35% of the original price is, you can calculate it this way, and then you check like this 229.3.23 minus this price, the discount amount. Yeah, this is the discount amount here. Should be equal to 149. We check it, it's correct. So you say it was 230 real, almost. It was 220 SAR, 229 SAR. Okay, next. That's it. Thanks for watching.